Hi, my name is Syed Hanafis bin Syed Hazib, student number 2022818702.
Hi, my name is Ahmad Aziz bin Ahmad Sofi and my matric number is 202-247-2312.
Hi, my name is Muhammad Hafizuddin bin Azizan and my student number is 2022492394.
Hi, my name is Muhammad Ikram bin Mustari and my student number is 2022816692.
Today, we will be presenting on the application of differentiation. Our video will cover what differentiation is and explain the application of differentiation in our daily life. We also include examples of questions using related rates.
Differentiation is a mathematical concept that involves finding the rate of change of a function with respect to one of its variables. It is a fundamental concept in calculus and has numerous applications in various fields, including physics, engineering, economics, and biology.
One common application of differentiation is in analyzing the behavior of functions and predicting how they will change over time. For example, in physics, differentiation is used to determine the acceleration of an object based on its velocity, or to calculate the rate of change of temperature in a material based on its heat capacity. In economics, differentiation is used to analyze change in supply and demand and to predict how price will change in response to change in market conditions. In biology, differentiation is used to study the development of cells and tissue and to understand how they change and grow over time.
In calculus, related rates refer to a method of finding the rate at which one variable is changing with respect to time, given the rate at which other variables are changing. This is often used to solve problems involving the relationship between different variables that change at different rates. For example, consider a scenario in which you are driving on the highway and you see a sign that says distance to next exit 1 mile. If you know your speed, you can use errated rates to find out how long it will take you to reach the next exit. In this case, the distance to the next exit is the variable that you are trying to find the rate of change for. And your speed is the known rate of change for another variable. It is the distance you have traveled.
To solve a related rates problem, you need to use the following steps. First, identify the variables involved in the problem and their rates of change. Second, write an equation that relates these variables. Third, differentiate the equation with respect to time. And finally, we substitute in the known values and solve for the unknown variable.
Now, let's look at example question for related rates. If x meter be the distance away from the light pole on the ground and y meter be the length of the shadow, find the rate of change of the length of a man's shadow as he moves away from a street light at a particular speed as shown in the diagram.
In order to find a rate of change of the length of the man's shadow, dy over dt, we first find a relationship between this length, y, and the distance from the light, x. We can do this using similar triangles, as shown in the figures.
Since the angles in both triangles are identical, the ratios of the lengths of the sides of the triangle are equal to. We can use this to express y as a function of x. 5.5x plus y equals to 1.8y. Finish the equation until we get y equals to 18 over 37x.
We can take the derivative of this with respect to time to find the relationship between the respective rates as dy over dt equals to 18 over 37 times dx over dt. Now, we can substitute the given rate. Dx over dt equals to 1.5 meter per second. And we will get dy over dt equals to 27 over 37.
In conclusion, the rate of change of the length of the man's shadow to one decimal place is 0.7 meter per second. Let's look at another example. The length of a rectangle is increasing at a rate of 15 cm per second and its width at a rate of 13 cm per second. Determine the rate at which the area of the rectangle increases when the length of the rectangle is 25 cm and its width is 12 cm.
The area of rectangle is given by the formula A equal L times W, where L is the length and W is the width. We can use the chain rule method to find the rate of change of the area with respect to time. The chain rule states that dA over dt equals dA over dL times dL over dt plus dA over dW times dW over dt.
In this case, we know that dL over dt equals to 15 cm per second, W over dt equals to 13 cm per second, L equal to 25 cm and W equal to 12 cm.
We just plug in this value into the equation. dA over dt equals in bracket 25 cm times 13 cm per second plus in bracket 12 cm times 15 cm per second. Finish the equation until we get equals 505 cm square per second.
In conclusion, the rate at which the area of the rectangle increases when the length is 25 cm and the width is 12 cm is 505 cm square per second.
Here are some references that we used to create this interesting related rates video.
That's all from our group and thank you for watching. See you next time. Stay safe.